All right, boys and girls, now we're going to look at multiplication and division equations. And so these are going to be kind of the same as addition and subtraction. You're going to look for a lot of the same things. You're going to do a lot of the same strategies. It's just multiplication and division. And so for this particular one, we're going to start with an example out of the book that they've used kind of a strip diagram for. And there's also a word problem for it. And so let's go through this one. It says a gardener is planting 6 rows of spring bulbs. Each has 15 bulbs. And so they want to know how many bulbs is he planting. And they want B to be the total number of bulbs. All right, so there's a few things I'm going to mark here. So I know that they're looking for a total. So again, when I'm thinking about that, when I'm reading my questions and I'm already thinking about either their strip diagram or just a kind of a basic part whole, anytime they're looking for a total, I'm going to think about either addition or multiplication. Well, at the beginning of this video, we said that this is going to be multiplication. And so I think it would be smarter to use multiplication on this one, even though you probably could use addition to find the answer. So I'm going to stick to multiplication here. All right, so this is what I know. I know that there's 6 rows. So I can kind of mark that here on their strip diagram. Those are all 6 rows. And then when there's 6 rows, there's going to be 15 bulbs in each. So the one thing I try to always preach in my classroom is look for that repetition. Look for something happening over and over and over and over and over. And when you see that, in this case, 15 is being repeated, you know that that's going to give you your total. So I could already start setting up an equation here that I'm going to take 6 and I'm going to times it by 15, and that should give me my number of bulbs that he has. So 15 times 6, that's going to be a 2 by 1. I would strongly suggest writing it out and solving it instead of trying to do it in your head, because you're going to really have a greater chance of making a mistake there. 6 times 5 is 30. We're going to carry. 6 times 1 is 6, plus 3 is going to give me 9. So we're going to have 90 here as our answer. So he's going to have 90 bulbs. And so 90 would go over here in my total, and that's going to represent, again, we can see it multiple ways here. We can see it in a strip diagram, part whole, whatever you'd like to do. Okay, this particular one, I'm going to kind of take an opposite approach to it. I'm definitely going to read. We're going to see what's happening here, but my first approach is going to be their strip diagram, because believe it or not, sometimes they could give you a strip diagram and there not be a word problem. And so it'd be really good just to be able to analyze and break down what you see. So right off the bat, when I see this strip diagram, something that catches my eye is they gave you 96, and they gave you 96 as a total. And so if I related this to part whole, it would be kind of like this. They're starting you off with a total. And when they start you off with a total, in my mind, I'm going to go back to these two. It's either subtraction or it's going to be division. And so I really have to kind of stop and think here, well, where's my part at? Because if I do part whole, and if I pick division here, which I think is what we're going to use, I still have to have a part. So my part here is, without reading, I think is 3. And that's because if I look into the groups here in this strip diagram, they gave me 3 groups. And so let's go and read and see what happens here. I think we're going to have a good setup of 96 divided by 3, but let's just double check this. I could be wrong. It says the cost of 3 pencils is 96 cents. Each pencil costs the same. What is the cost of 1 pencil RP? Okay, so I think we were onto something there. I think that we did some good thinking when we set up our part whole. Definitely have 96 as a total. That's how much was spent, 96 cents. They bought 3 pencils, but they care about 1 pencil. So I think we're going to set up a pretty simple division problem here of 96 divided by 3. And so looking at this problem, we'll go through our steps for division. So 3 can go into 9 3 times. And that's going to give me 9. And I'm going to run out of some room here. Let me see. Yeah, I don't think I can fit it in. So I'm just going to write it as I go. That wouldn't give me anything when I subtract, so I would bring down the 6, and then the 3 is going to go into 6 twice. And since it's talking about 96 cents, we'll kind of think of it as money here. So we'll say that each pencil is going to cost 32 cents. So our equation that we would use here is we could write it a couple of different ways. We could just kind of write it very, pretty simple, 96, and then we're going to divide it by 3, and then that's going to give us our answer of 32 cents. So I'm going to write that in, and then pretty simple stuff. Again, it's kind of falling back to what you've seen before with strip diagrams and part whole. It's just now we're throwing in some multiplication and division. All right, this particular one is just a word problem, and there is something about this that kind of catches my eye right off the bat. And so kind of like before with the addition and subtraction, I think it would be smart to just get rid of and not think about these answer choices right off the bat. Again, it's kind of hard to do that sometimes, and sometimes when we work problems, those answer choices are really helpful, to get rid of the silly, what I call kind of like the silly, stupid answer choices. Just kind of get rid of those and use process of elimination. That's good, but in these problems, I would strongly suggest concentrating on solving them. Do whatever the word problem is telling you to do, and then go and find your variable, find out whatever your variable equals, and then go from there. Okay, so it says Mr. Toon took a vacation to Neptune. His vacation lasted for 144 hours. A day on Neptune lasts for 16 hours. Which equation and solution shows how many days Mr. Toon's vacation lasted? So let's kind of stop and kind of think about it's a little bit different problem because they're talking about traveling to Neptune. But I think if we break this down and we really think about what they're telling us, it's not too bad. His vacation lasted for 144 hours. So to me, as soon as I read that, I'm thinking, okay, well, that's a total. And then it says a day on Neptune. So a day on Neptune lasts for 16 hours. So I'm thinking that might be one of my parts. And so what they want to find out was how many days did Mr. Toon's vacation last. So again, I could do this several different ways. I'm just a big part whole fan. I like doing that. I think it's short and sweet. It's simple. And so a lot of times I kind of gravitate towards that. All right, there's my total. So I'm going to do division or subtraction. I'm thinking, let's think here. So if I took 144 and I subtracted 16, I'd still be like in the hundreds. So I don't even need to solve that. I don't think that's how many days Mr. Toon's vacation lasted. So again, the reasonableness kind of takes the subtraction out. The division, on the other hand, I think makes more sense. And so what we want to do here is we want to try to find out what is 144 divided by 16. So we've got a little bit harder division problem here because we're dealing with 16. And so you just have to kind of go back to your basics of what you know. And on this particular one, 16 can't go into 1. 16 can't go into 14. So you're actually taking 16 all the way into 144. So what I would suggest doing on this one would be, before you start, maybe writing out some of your 16s and thinking about how many times 16 is going to go in. Think about, maybe always do this in my class. We always kind of have this discussion. So think about like something that you could do mentally. Like I would throw out 16 times 10 because 16 times 10 should be a really easy math problem in your head because you're basically doing 16 times 1 and then adding a 0. Well, 16 times 1 is 16 with a 0. That would be 160. So you got actually pretty close to 144. So I would suggest maybe thinking of stuff like that because now when I'm going to go try one, this one might make really good sense. Because since I got so close to it, I bet 16 times 9 is going to be it. So 16 times 9 or 9 times 6 is our first step is going to be 54. 9 times 1 is 9. plus an extra 5 there is going to give me that 14. So yes, 16 does go into 144 equally 9 times. So 9 are 9 days, because that's basically what we're solving for. How many days was he there is going to be our answer. Okay, so now it's my job to go back, and of course, you probably would not want to scribble out the answer choices on the day of the test, but I like doing that just to show, when you're solving these, really, they could get in the way sometimes, and sometimes they could be misleading. So always try to go and find out what your variable is going to equal. So we know that our days are 9. Okay, well, I mean, gosh, if we know that, and I go back to this problem, there's a couple of things that catch my eye, but man, there's really, if I look at kind of the right side of these answer choices, I'm going to put a circle around it here. They're telling me what D equals. D equals 9. D equals 2,304, 128, 160. I mean, there's only one that makes sense, and that's going to be A. The one thing I will say that catches my eye probably the most here is this part right here. So what you're looking at is a number with a variable right next to it, and there's no symbol. And so I'm going to erase it so we can see a little bit better what's happening. I think A is going to be our right answer, but we do need to talk about this. So you actually probably just saw some of this when you did your order of operation problems. And the way I just kind of describe this to my students is it's what I refer to as a no symbol. There's no symbol. There's basically a number, and then there's just something right next to it. In this case, there's 16, and then there's the D right next to it. So in my mind, I'm thinking, okay, if there's no symbol there, then you're looking at a multiplication problem. You probably saw some no symbols when you did order of operations. And so no symbols, that's kind of how I teach it, always means multiplication. So even though we didn't multiply on this problem, I think we could have used multiplication to check our work. In other words, if I go with A, they're saying, okay, let's take, and I'm going to get a different color here just to make it stand out. Let's take 16 and let's times it by 9 and see if that equals 144, which it would, because I've already proven that down here when I solve my math. And so when I go back to the answer choices, that looks kind of strange. It kind of looks like, gosh, what are they even showing there with that no symbol? I'm not going to go pick that one, when really that is the correct answer, because even though we didn't divide, you could still use multiplication to find this answer. So again, watch those answer choices. Sometimes those answer choices can be a little bit misleading. I know, though, from doing this math, 9's got to be my answer. And 9 is reasonable. I mean, if you go look at some of those other answer choices, they're just not reasonable. All right, this one here is one where they're looking at really not a word problem. They're just looking at a strip diagram that's made for you, and they're wanting you to solve for B. And they want you to go pick an equation that would make sense here. It's an equation that matches their strip diagram. So right off the bat, something that catches my eye, this is kind of how I would solve it, is they did not give me a total. And I see repetition. I mean, every time I'm putting a check mark here, it is 14, 14, 14, 14. So I'm thinking to find B, not to go look at A, B, C, or D, not to look at my answer choices, but just to go solve for B, I'm thinking I'm going to take my 14 here, and since it was repeated 5 times, I think that could give me the answer choice, or excuse me, not the answer choice, but the to find the variable of B. So let's do that. 14 times 5 is not a hard problem. 2 by 1, we're going to carry. 5 times 1 is 5, plus an extra 2 is 7. Okay, so my B, I'm going to write it in here, equals 70. Okay, now that I know what my variable equals, I've got to go find something that makes sense here. And this is that part where, to me, this is the trickiest part. And that is understanding what these equations mean and how to make it fit in for what we just did. Because to me, this is what really throws students off. You maybe did something to find your answer. Like we multiplied to find 70. But that doesn't mean that I'm going to go over and pick a multiplication problem. I've got to be really smart here. Okay, so I'm actually going to start from the bottom up. So I'm going to start with D. D says there's a no symbol here. So D is saying if I take 5 and I times it by B, which we know B is 70, that's going to give me 14. That does not make any sense at all. That is not reasonable. Look at C. C says 14 divided by 5 equals B. Well, we know B is 70. That does not make any sense. Let's look at the answer choice B. 14B, in other words, no symbol, 14 times 70 equals 5. 0 cents. I'll look at A, though. A, I think, makes sense. It's not what we did, but it makes sense for this problem, this strip diagram that they gave us. Because what they did was they took it and they flipped it. They said, hey, if you had 70 and you divided it by 5, would you get 14? And that definitely is correct. You know, if you flip around this strip diagram, if you start with 70 at the bottom and then you go and you put it into 5 groups, you know, how much would be in each group? And it would be 70. So this definitely makes sense. It's not what we did. I mean, we used multiplication, and here we are. We're going to go pick a division equation, basically. But if you think about it, the opposite of multiplication is division, or the inverse is division. So we could use division to check our work. So that one makes sense. And again, it's all about figuring out what that, you know, value is. In this case, we figured out B. So B equaled 70. And then plugging it into those equations to see which ones make sense, which ones are balanced. You know, that's kind of how we started this whole lesson on equations, is we wanted a balanced equation. All right, the last one here. So this one, again, without even looking at A, B, C, or D, this strip diagram just kind of shows me some stuff right at the beginning. 88 is going to be my total. And then from there, they're putting it into groups. Well, I can just look. They've put it into 4 groups. So without looking at my equations on A, B, C, or D, let's just go solve this thing and see what I get. I think this is going to be 88 divided by 4. I want to find out how much is in each group. Well, this is really pretty simple because they kept the numbers pretty friendly. So we're going to say that, 4 is going to go into 8 twice. We're going to drop it down, subtract, check, just kind of do all your basic division. We're going to bring down again. 4 can go into 8 twice. All right, so I know that there's going to be 22 in each of these groups. Okay, now, with that being said, if I know that D equals 22, then I've got to go find something over here that makes sense. Okay, let's start with A. 22 plus 4. Well, 22 plus 4, I mean, you could do that in your head. That's going to give you 26. That's not 88, so A is out. 22 divided by 4 is B. That doesn't make any sense either. 22 divided by 4, that's, 4 doesn't even go into 22. It's definitely not going to give you 88, so that's out. Watch this no symbol. This is really saying 4D, or 4 times 22, equals 88. Well, that makes some sense. I think that could be something that makes sense here, because if I were to go solve that, 4 times 22 is going to be 88. It's not what we did, but it's reasonable. It makes sense. So I'm going to put a little check mark by C. D, on the other hand, answer choice D, is D equals 4 times 28. So D equals 22. We know that from our solve. And then, wow, 4 times 88, that's going to be way bigger than 22, so that one's not reasonable. So again, it falls back on reasonableness and understanding what's taking place. Again, we're doing something mathematically. In this case, we did a division problem, but the equation that we're going to go pick is its inverse. So it's kind of like the check. If we wanted to check 88 divided by 4, what we did here, then we would check it by doing 22 times 4, which is the one that they're using. And so I would just strongly suggest on each of these problems, when you start seeing these equations, and you'll notice them because they're pretty easy to spot on your test, really go slow, solve your problem first. Solve your math problem first. Do some problem solving skills. Solve it first, and then go look at your answer choices to decipher, okay, which is the one that makes sense, it's reasonable, and you can plug in your answer, whatever you're getting for your variable, and it makes sense, it's reasonable, but it also balances it out. So practice these. These aren't too bad. A lot of times they keep the numbers pretty low. You just got to go slow. You just got to really think about these.